Hello friends, welcome to part 6 of Solve Paper Analog Systems and Applications, Dibrugarh University, 4th semester, paper C-10. Okay, so we have already solved up to question number 5, then we can solve question number 6 and 7 here. So before we start, please subscribe the channel, also hit the bell icon so that you get notified when new video will be uploaded, and share with your friends and hit the thumbs up button and support me to create support me to grow my channel, inspire me to create new contents for you, right? So now let's start. And one more thing, if you want to follow me on Insta, then you can follow me. This is my Insta ID. Oscillator 123. This is my Insta ID. Okay, so now let's start. Here is the circuit diagram of this is RC coupled CE transistor amplifier. So you can write RC coupled CE transistor amplifier. Okay, so this is the circuit diagram, and here is the operation. Take the screenshot, pause the video and take the screenshot. And here I have written about the frequency responses. Okay, so now let's move on to the next question. So what is negative feedback? Explain with necessary frequency response curve how the bandwidth of RC coupled amplifier modified when negative feedback is used. So let me show you the next question, answer to this question as well. So here is the definition of negative feedback. This is 6B answer. So now let's go to the next part of this question, where you need to draw the this diagram, frequency response here. So this is the frequency response curve. Okay, so this bandwidth increases. So explanation is here. This is the effect of negative feedback on gain and bandwidth. Okay, so I'm not going to explain, just take the screenshot and you can write the answer. So take the screenshot as well of this slide as well. Okay, so here is the answer. This is here you see this is the first slide, this is the definition, first part of the question. This is the diagram, and then take the screenshot of this one, then this is the last part of the answer. Okay, so hope you have found this. Now let's move on to the next question. So our next question is 6C. Okay, so here you have to describe a Hartley or Colpitt's oscillator circuit and explain its operation. So let me give you the answer. Okay, just take the screenshot. So here is the answer of 6C, right? So take the screenshot of this, and this is not ended here. So let's go to the next slide. So here is the next part, last part. Okay, so take the screenshot of this one as well. So now let's move on to the next question. Okay, now let me answer question number 7A. Draw basic inverting amplifier with an input resistance R1 and feedback resistance RF, assuming open to be ideal. Derive the expression for the voltage gain of the inverting amplifier. So now let's give you the answer. Let me give you the answer. So here is the answer of question number 7A, right? So inverting amplifier. So here you see this part will be shown in the next slide. Okay, so take the screenshot, and here you see. So this part was cut in this slide. So from here I have shown in this slide. Here you can see clearly, and this is the required expression of voltage gain, right? So now let's move on to the question number 7B. So here is the 7B. Explain with circuit diagram of an op-amp as differentiator. So let me give you the explanation, that means let me give you the answer. Okay, So this is answer to 7b. Okay, so op-amp as a differentiator. So this is not ended here. Take the screenshot and let me go to the next slide. So here is the last part of this answer. Okay, so now let's move on to 7c. So this is 7c. We have to define CMRR and slew rate of an op-amp. What is the importance of this CMRR? Okay, then or you have to answer this question, or you need to solve this problem. I'm going to show you this solution of this problem, how to solve this. Okay, so first let me show you the answer of this 7c. Okay, so let me give you the answer. So this is the answer to 7c, right? This is the answer to 7c. Yeah, and take the screenshot of this, and this is the last part. Okay, take the screenshot of this one as well. So now let's move on to the OR part. That means here you see in this question you have to solve 7c. There are two questions. There were two questions here. You can see. Let me show you here. This is the paper. Either you have to answer this question, as I have already shown. Now let's solve this problem. Okay, so this here you see. This was the answer to 7c, and you have to answer this, or you have to solve this one according to the paper. Okay, you have options. So now how to solve this one? So here we have seen two input voltages, V1 and V2, right? So solution, let me write here. So here RF, this is the RF, is here 10 kilo ohm, and here R1 and R2 both are 1 kilo ohm. It's 1 kilo ohm. Then we need to find the voltage gain, right? Sorry, voltage, not voltage. Then we need to find the output voltage. So here formula to give you the output voltage is like this: V out, or you can see here in the diagram it is VE written VE. So that's why in some books you're gonna have this V out. Okay, same thing. So minus RF, that's gonna give us the minus RF divided by R V1 plus V2. This is the formula that we're gonna use. But here you see, just give me a second. So before that, just wait. Let me keep here. So before we use this one, so let me find R here. Okay. So here you see actually what happens here. So here R1, R2 both equal to 1 kilo ohm. So this is you can write this is equal to R. So actually formula is this one, V out, or according to this diagram you can write VE is equal to minus IF into RF is equal to so minus here RF, instead of IF what you can write, IF instead of IF you can write V1 by R1 plus V2 by R2. So here R1, R2 both equal to R, both are equal, so we have taken both equal to R. Then this RF here you can write V1 by R plus V2 by R, right? That's how this formula comes here. So if you take 1 by R common, then you're gonna get this formula, right? That's, you don't need to show this part, just I have explained how we have got this one. Okay, so now just wait. Okay, now let me solve this one here. So VE will be equal to minus RF. What is the value of RF here? This is 10 kilo ohm, right, divided by R is 1 kilo ohm here, so 1 kilo ohm. Since here you see RF and R both are in kilo ohm, so that's why I have not converted, because kilo ohm that's gonna be cancelled. Okay, then here you see V1 is 0.2 volt here, so I forgot to mention V1 is 0.2 volt and V2 is 0.5 volt. 0.5 volt. Let's put here. So V1 instead of V1 we're gonna write here 0.2, and instead of V2 we're gonna write 0.5, right? So here it's gonna be minus 10 into 0.7, and that's gonna give you minus 7, right? So that's gonna give you minus 7 volt. So this is output voltage, so unit should be volt. So this is the answer to this question. So hope you have understood this, and if you enjoyed this video then please share with your friends and hit the thumbs up button. So thank you for watching. See you in the next video.